Fluid conductors are those parts of the system that are used to carry fluid to all the various components in the hydraulic circuit. These types of conductors include hydraulic hose, steel tubing, and steel pipe. This course will help you understand the benefits of these different conductors and where they are best used in a hydraulic system.
Transmitting power from one location to another is a key element in system design and performance. Fluid conductors describe the different types of conducting lines that carry hydraulic fluid between components. The three principal types of plumbing materials used in hydraulic systems are steel pipes, steel tubing, and flexible hose. A safety factor of 4:1 is recommended on the pressure rating of the plumbing material. To determine the working pressure of the conductor, we must take the rated burst pressure and divide by the safety factor of 4. Hydraulic hoses are used in applications where lines must flex or bend. In considering the use of hoses, one must first look at system pressure, pressure pulses, velocity, fluid compatibility, and environmental conditions. Hose construction has been standardized by the Society of Automotive Engineers. As an example, 100R2 or 100R4. This designation describes the cover, construction, pressure rating, and application. Hoses are usually pressure rated with a safety factor of 4:1. Different types and amounts of reinforcement give the hose specific pressure ratings. The reinforcement may be a natural or synthetic fiber or metal wire. The reinforcement may be braided or spiral bound. Required hose size depends on the volume and velocity of the fluid flow. Unlike pipe and tubing, hose sizes are designated by ID or inside diameter. Sizes are designated in 1/16 of an inch by using a dash and a number, equivalent to the numerator of the fraction. Example is -8 or 8/16 or half-inch ID. Hose life is good, but all rubber slowly deteriorates with contact from various substances such as solvents, water, sunlight, heat, etc. Hoses are not as permanent as metal conductors and should be replaced every few years. Proper hose installation is critical. Improper bends, twisting, or lack of proper anchoring may lead to hose failure. Steel pipe is often a preferred conductor from the standard point of performance and cost. However, it is often difficult to assemble because welding is required to give maximum leak protection. It also requires costly flushing to ensure a contaminant-free system at startup. Pipe is specified by its nominal outside diameter, but its actual flow capacity is determined by its inside area. For example, schedules 40, 80, and 160 and double extra have the same outside diameter, OD, and can be threaded by the same pipe die. The difference is the inside diameter, ID, and area. Schedule 40 pipe is standard and has the thinnest wall, with more flow area, but less pressure rating. Tubing is used as a conductor when rigid lines are required. It is often easier to assemble and form, and requires no welding to achieve leak-free connections. As with all types of conductors, certain requirements must be met. The line must be large enough to carry the required flow and strong enough to withstand internal pressures. Tubing is measured and specified by its wall thickness and OD outside diameter. Pressure ratings are based on tubing grade and wall thickness. One piece of tubing is joined to another tube connector or component with a tube connector and fastening nut. Often the tube is pre-flared to 37 degrees to accept a 37-degree flare connector. In this